This question showed me what you actually need to think before writing code. Process strings with special operations too is a LeetCode hard that I initially tried to tackle the intuitive way. Build a string in one go, and after all operations return the character at the specified index. That did not go well. There are 4 rules to keep track of for the problem. Lowercase letters get appended to the end of the string, asterisk removes the final character of the string, percentage sign reverses the current string, and finally the reason why doing it the intuitive way is bad. Hashtag duplicates a string and appends it onto itself. This means that the memory usage can scale exponentially, making it impossible to build the final string for large inputs. Essentially, if the input string spams hashtags, you're cooked. So what's the alternative? Tracking the length of the string and how the target index is translated by those operations. We will work in 2 passes, a forward pass to compute the length of the final string, and a backwards pass to compute the translation of the target index k as we move backwards through the operations. Take a look at this input string and target. Stepping forward through it, we will append a to the result, so we add 1 to the length, then duplicate it so we can multiply the length by 2, append b, so we add 1 to the length again, flip it, the length doesn't change, and remove the last character. We take away 1 from the length. The final string has a length of 2. This means that if k is greater than or equal to 2, we would be out of bounds and return a full stop. Now let's try stepping backwards while keeping track of k. The last character in the string is an asterisk. This means that we are undoing a deletion, so the length becomes free. The percentage sign flips the result, so the length remains the same. Normally we would flip the string, but since we are working backwards and don't have access to the final string, we should instead flip the target index. Let's say the length of our word is L and the target index is k. Then in order to flip the target index, we do k is equal to the length minus 1 minus k. We need to take away 1 to account for the fact that indexing starts at 0. So the target position k is now 1. Then we get b. Since we are stepping backwards, we will check that our target index isn't equal to the length for our string, minus 1. 2 does not equal 1, so we will continue and subtract 1 from our length. Our new length is now 2. Now the hashtag. We divide the length by 2 to get 1, but remember that this also changes the target index since we are undoing the duplication. Since both halves are identical, if the target index k happens to land on the other half of the string, it should be remapped from out-of-bound coordinates to coordinates which are inbounds. So our target index 1 modulo our length 1. This is equal to 0. Modulus is just taking the remainder from a division. Another way to do this is by subtracting our new length from k if k is greater than or equal to length. In that case, we would do 1 minus 1 equals 0. Finally, we have a. Let's check if our target index is equal to the length of our string minus 1. 0 is equal to 0. Since we found the target value, we will return a. Let's change k to 0 and see if we get a different answer. The first step is the same. Add 1 to the length since an asterisk means removing a character. Next, we translate the target index. 3 minus 0 is 3. Subtract 1 to account for starting at 0. K becomes 2. Next, we have b. Check if the target index is equal to the length minus 1. And it is, since 2 is equal to 2. First, we iterated over the string to calculate the final length, returning a full stop if k was greater than or equal to the length. Then, we iterate over it again, back to front, while applying the inverted rules and checking to see if the length minus 1 is equal to the target index every time we hit a lowercase letter. This solution is way less memory intensive and runs in O event time because it's only a forward pass and a backwards pass of the string. If we convert the logic into code, we can submit it and see if it holds up against other test cases. And we can see it does. So if you guys enjoyed the video, make sure to like and subscribe, and maybe check out a different LeetCode video I made. See ya!